Here we go. Let's try this out. Heard a little bit of this. Oh my goodness. There's some stuff. You know, that takes you thinking about back in my day, which was a long time ago for you guys, of course. We used to cruise around all the time, there's like a cruising song right there, right? You got your car in there, you got your windows down because it's nice outside, right? And you got this music, this song's going, people can listen to it because you're cruising, you got the windows down, you're down on Highway 30, you stop at Dutch Bros, get a little drink there, you're chilling, and it's just going for you, right? It's got your sunglasses on. Whew, man, it's been better than that. But, hey, listen, hey, we, questions, documents, I put it up there. I think it's going to work this week. I went through and tried to put every single thing that you could share on it so that you can. Hopefully it does work. Sorry about last week's. I emailed some people and said, hey, we don't have a lot of left here, we're almost down to 2 weeks now. I mean, that's just about it. We got this week, which is short. We have today and tomorrow, and that's it. So we're going to do some stuff tomorrow too. Try we can get 2 lessons in this week, and then Friday's Furlough Friday, and then we have one more basic, one more strong week, and then there's no final or anything. That last week's probably not going to look like a whole lot. So I don't think we're going to get a project done. I'm not real sure we're going to, which is probably good news to you, but that means your grades are based upon 2 things, and that's your assignments and your quizzes. And for those you haven't done any of those quizzes, it's going to hurt you. So make sure that you take care of that stuff. So, all right. Hey, what do we got? We got a new unit. We're done with radicals. All right, we're done with the rationals. We're done with radicals. We're going to move on to the T stuff, which is called trigonometry. Yes, indeed. We're going to do some trigonometry. And let me just write that. Do I still have my pen? Oh, yeah, it's still on. Maybe here we go. Some trigonometry. All right. Trigonometry is probably not even spelled right. But anyway, that's what we're going to do. And we're just going to start out today with, I did do it right, reviewing some stuff, and then we're going to kick it a little bit. We're just going to kick it up a little bit and look at something called a cofunction. So let's start out with some right triangle trig that you learned last year in your geometry class. And I know some of you did, because I know it. Yes, indeed, that you did. All right, so let's do that. All right. Boom, going to move that up to there. And right triangle trig. Here's what we got. We got a right triangle. All right. I don't know why it's not drawn. There it is. And I'm going to put a right angle right there. I'm going to put an angle down here. I'm going to call it angle A. A as in apples. And there it is. So what we're going to do is talk about the right triangle trigonometric ratios that we learned last year. And one of them was sine. Right? Sine of angle A is equal to the opposite side. I'm just going to call it OPP over the hypotenuse side. All right, so opposite, remember, is this guy right here. All right, hypotenuse is always the side opposite the 90. I got geometry guys learning some of this stuff now. They're struggling a little bit, but they're hanging in there. All right, so there's that one. And then we have cosine of A is equal to the adjacent side over the hypotenuse. So the adjacent side is this thing down here. This is the adjacent side, because it's adjacent means next to, and this guy is next to A. And then there's always somebody who says, well, I don't understand why this one's not the adjacent side. Well, because that's the hypotenuse. Yes, indeed, we got it covered. So we got to know where the hypotenuse is. It's always opposite the 90. And then the last one we learned last year was tangent, which was pretty much the easiest one, because that's the one we did in the beginning. And it was also opposite, but this time over adjacent. So it was opposite over adjacent for that. All right, those were our trig values. So how exactly did they work? Well, we had 3 trig examples for tangent, and that was the only 3 in the whole world. But sine and cosine had a bunch. So I'm just going to go ahead and say, let's say we got a right triangle here. I don't know what this is. It's kind of like a little leftover there. I'm going to get rid of it. There we go. I just got rid of the whole thing. Here we go. Boom, that's better. I'm going to put my right angle right there. And I think I'm going to put a 35-degree angle here. And then I'm going to put 20 right there. So what I want to do is find the other 2 sides. All right, I can pick either one. It doesn't matter. Let's call this one A and call this one B. We can pick either side that we want to find. I'm going to do B. All right, so we're going to find B first. All right, so then what I do is I look at this and I go, well, let's see. Here's my angle. I always locate the angle first. That's what I was telling the geo kids. I say, you got to find that angle first. There it is right there. And oh, yeah, there it is. All right, now that you know where that angle is, look for the side that you know. Okay, well, I know this side right here, and it is the 20-degree side, or 20 length side, which is opposite the hypotenuse, is opposite the 90, so it's the hypotenuse. Okay, and I'm trying to find the B side, which is right here. Okay, and that is the adjacent side, because remember, it's right next to the angle. So if we have adjacent and we have hypotenuse, I know I'm going to use cosine. So I'm going to go cosine of the angle, which is what I always do here, equals the adjacent side, which is B, over the hypotenuse, which is 20. So then here's the situation that I have. All right, so now all I need to do is find the cosine of 35. So either you use your calculator, but since we are in Algebra 2 and we love Desmos, that's what we're going to do. All right, so I'm going to get rid of that guy, get rid of that guy. So when I'm using Desmos and I'm doing trig stuff, you have to make sure you're in the right setting. So if I push the little wrench, all right, notice it says degrees. That's what I want. It has to say degrees. I bet yours doesn't. It probably doesn't. All right, here we go. Functions, cosine, 35. I get 0.819. So 0.819 is going to go there. I'm going to throw that over 1, and I'm going to go B over 20. So now, cross multiply. We did that 1,392 times last year in my class, so you should be good at that. 20 times 8.19, or 0.819. So I'm going to go 0.819 times that baby by 20, and I get 16.38. So I'm going to scoot this up a little bit and write down that B is equal to 16.4. I'm going to round it a little bit. All right, so what did I do? I started with my triangle, located the angle first. I say, well, I know this 20 right here, which is the hypotenuse. Hypotenuse is always opposite the 90. Okay, this is opposite the 90. I'm trying to find the adjacent side, which is B, and that means I have cosine, because cosine is adjacent over hypotenuse. I take the angle, cosine of the angle. I use Desmos, make sure I'm in degrees, and then I'm all set. So, I didn't find A, though. Rats, I didn't find A. Well, heck, once you know what B is and you know what C is, you don't need to do any trig. You use Pythagorean theorem. Now, you could use some trig on here, but I think it's kind of a waste of time. I'd much rather use this guy because I can figure this out in one little swoopy by putting it into my putting it into Desmos, right, and figuring it out. Watch what I'm going to do here. I'm going to come down here and I'm going to put the square root, because I know that's what I'm going to do at the end of this whole thing. 20 squared minus 16.38 squared. And look at that, 11.47. Isn't that something? 11.47. There's my answer for A, which is probably quicker and more efficient than if I was to use one of my other trig functions. All right, let's clear up these. Oops. I'm going to clean up the leftovers here. Get rid of that one too. All right, wow, that was fun stuff. But we got to try another one here. I think we got to keep going. Let's try another. So I'm going to draw another right triangle. Okay, try to make it. There we go, and there. Put my right angle there. This time I'm going to put 40 degrees up here, even though it doesn't look like 40 degrees. And I think what I'm going to do is put 8 here and put A and C there and say, okay, we got to find one. All right. Let's find C. Okay, so I'm going to say, I'm going to find this guy first. All right, I could have picked A, but I picked C. All right, so first thing we do, locate the angle. The angle is there. I know that I have this side here, which is opposite because it goes directly across from it. So that's opposite. And of course, there's my hypotenuse. So I have OPP. Yeah, you know me. Get out with OPP. Yeah, you know me. Who's down with OPP? Every line's on me. Get out with OPP. Yeah, you know me. Line of 40 is equal to the opposite side, which is 8, over the hypotenuse, which I don't know. All right, so I put a C down there. All right, opposite over hypotenuse. Opposite is here directly across from it. So now, let's go ahead and use Desmos, and we want to find the sine of 40. So I'm going to get rid of this guy, and this guy, and I'm going to try to find the sine of 40. So sine, I don't need to check to see if I'm in degrees, because once you're in it, you're in it. Should be anyway. It should be. But if you're bouncing in and out of it, you might not be. See, I'm okay. Sine of 40 is 0.64. And put that guy over 1 equals 8 over C. And cross multiply. 8 equals 0.64 C. And then I just got to do a little division here to get the answer. There we go. So now I'm going to go like this. I'm going to go 8 divided by 0.64, and I get 12.5. Oh! C is equal to 12.5. So there's my hypotenuse, all right? And just like before, you know, why would I not want to use Pythagorean theorem here? Okay, A squared plus 8 squared equals 12.5 squared. So, A squared plus 64 equals 12.5 squared. And I'm going to use Desmos to figure this out. Again, I'm going to come down here. I'm going to go square root because I know that's what I'm going to have. 12.5 squared minus 8 squared, or 64, 9.6. Whew. A equals 9. Look at that. I knew that was going to happen. See, now it's all screwed up. 9.6. There it is. All right. So if it's going too fast, just pause it, right? You can pause it. It's like a DVR, right? You can pause it. You know, you're watching a cool show, and and you want to go get something to eat, or you got to go to the bathroom or something, you just pause it, okay? Take a dog for a walk, I pause it. It's awesome. I love those DVRs. All right, so there's how we do that one. Let's just do one more, and then we're going to talk about some co-functions. Co-functions. Let's erase all these stragglers. Here we go. So this time, let's do one where we're going to flip it around a little bit here and make it look interesting. Look at all these stragglers here. Why is this stuff happening? I don't understand. Then I'm going to put my right angle up there. Okay, I'm going to put angle B right here. And I'm going to go, this one here looks like a 32. And this one over here looks like a 20. All right, and this time I want to find this angle. So then you go, oh, wow, heck, you always said locate the angle. Yep, I'm still saying that too. Locate the angle, there it is. All right, what side is it that we have? Well, we have this side, which is opposite. Yeah, you know me. Get out with LPP. Yeah, you know me. Who's down with LPP? Every last on me. Get out with LPP. Yeah, you know me. So well, what about this side over here? What's that? That's the hypotenuse. Remember, it's opposite to 90. It's the hypotenuse. So you leave it alone. So we don't even know that one. We don't need it. We want the angle. We want angle B. All right. So opposite over adjacent. Opposite over adjacent. That's tangent. So I'm going to go tangent of angle B is equal to the opposite side, which is 32, over the adjacent side, which is 20. But this time we don't know what B is, so I can't go tangent of B in decimals because it will go, what the heck are you talking about? So it doesn't know that. So what do we got to do? We do something called an inverse tangent. And we did a little bit of stuff on inverse functions, at least I think we did, but I can't remember because I'm, just don't remember everything. Anywho, I'm pretty sure we did, though. When we do inverse functions, we're going to take the domain and range and we're going to switch. All right, so we're going to put 32 here over 20, and that's going to be B. But we're talking about an inverse, so that's why I put that little -1 there. All right, that's a symbol for inverse. All right, can I still do it in decimals? You bet your bottom dollar you can. You come down here, all right, function. There it is right there. And then I'm going to put in here 32 divided by 20, I think what it was. 58 degrees. Oh my goodness. It was too. Angle B is equal to 58 degrees. There it is. And that's how you do it. I don't care about finding the hypotenuse on that one. You use Pythagorean theorem. So anyhow, those are our right triangle trig review. All right, so now what we're going to do, thank you very much for doing that. Get back to where you were. There we go. Now we're going to talk about some cofunctions. All right, so what the heck are those? Well, oh my goodness, get rid of the stragglers, come on and right. I'm not going to pick this color anymore. Cofunctions are the reciprocals of those other functions. So they're basically flipped. So for example, sine, right, over h, right, its cofunction is cosecant, abbreviated CSC, and it's equal to h over o. So we're flipping it, all right? Cosine A over H, well, that's equal to secant. Its cofunction is secant, abbreviated as SEC, and that would be A over H, except I got to flip it. Dummy me forgets to flip it. There we go. H over A. All right, so we have cosecant and we have secant. And then our last one, tangent. Come on, make a T. Make a T. There we go. Tangent is opposite, oh my God, over adjacent like that. Okay, and it is cotangent, which is why they call these the co-functions, because they put co in front of them, except for cosine, because it already has a co there. Cotangent and its abbreviation is COT, C-O-T, and now we're going to flip that. So those are called co-functions, all right? So what am I going to do with these co-functions? Well, we're going to do this. We're going to find all 6 functions, which is dark blue. All right, we're going to find all 6. There. I'm going to draw this triangle. Put my right angle there. I really don't care about the angle, but I'll put angle A here anyway. And in this case, what I'm going to do is I'm going to put this down here at 15. I'm going to put this down here at 9. All right? So what I got to do in this triangle is find all 6 co-functions. Well, I can find tangent because I know the opposite side and I know the adjacent side. But that's the only one I can really do, is the tangent ones. I can't do sine and cosine because I don't know what the hypotenuse is. However, you do know that you can find that, right? Yeah, Pythagorean theorem, gosh, dang it. You know, you think that this thing's going to go away someday, but it doesn't. It just keeps coming back. Oh my goodness. So we got this here. 81 plus 225 equals c squared. And let's see, I'm going to scooch this up a little bit. There we go. Let's see what c is. I know it's going to be a square root. And let's see, that's going to be a 6, and that's going to be a 0. 306. Okay, there it is. And you might say, well, why? I use my calculator. I use Desmos to find stuff on the last one. What are you doing here? Well, we want to try to keep these values to be exact. So we want them to be as best as we can. So we're going to leave them as square roots. Now, here's the other kicker. 306. We really should probably reduce that, dude. So, we're going to simplify it. I wonder if there's any numbers that go into 306 that are perfect squares. No, I'm going right to here. 306 divided by 16. I'm going to try that out. No, that's no good. 306 divided by 36. 6. I see 3 went into it, so that's a good sign. 306 divided by, if 3 goes in, maybe 9 does. Ooh, 9 goes in there. Okay. If 9 goes in there, I better try 81. Just in case. Oh, no good. So 9's my winner. So 9's going to go in there. And I saw that was 34 times. So that means, hang it in there, I know you are, 3 square roots of 34, all right, is my C value. So I'm going to hop back up to here. I'm going to put 3 square roots of 34. Now I'm ready to do all of my work. Watch how this goes. It's really slick. Sine of A is equal to opposite 9 over 3 square roots of 34. Cosine A equals adjacent side 15 over 3 square roots of 34. Tangent of A is equal to opposite side 9 over 15. So there's those guys. Now we're going to do my co-functions. All right, so I'm going to flip things, so I'm going to flip them. So now I'm going to take and go cosecant A equals that sign. So I'm going to flip it. 3, come on, 3, give me a 3. 3 square roots of 34 over 9. Oh my goodness. Over 9. Why is that happening? Secant A is equal to, flip that one, 3 square roots 34 over 15. And finally, cotangent, way down here at the bottom. I knew that was going to happen. Cotangent A, give me an A, equals, I'm going to flip that guy. 15 over 9. Now you say, oh, man, that's kind of a lot of work. But you know what? Holy buckets, we're not even done yet because we can reduce. All right, this goes into here, gives me a 3 over the square root of 34. All right, and you cannot have a square root in the denominator of a fraction. So we have to multiply by this and this. So finally, we get, I wonder if I can, I'm going to lasso this stuff. Get it the heck out of the way here. Move over there. Thank you. So finally, I get, let's see, what I got. Oh, here we go. 3 square roots of 34 over 34. There's my answer. All right, there it is. So what do we do there? We reduce the 9 and a 3, so we got a 3 on the top. Can't have a 34 on the bottom, so I multiply by the square root of 34, and nothing much happens there. I just have 3 square roots of 34 over 34. Same thing here. This is going to reduce, give me a 5. Got to rationalize again. Basically, all that happens is that radical moves to the top, and then we get 34 down there on the bottom. It's basically all that happens. 9/15, you can leave that one alone, or you can reduce it if you want to. That one doesn't matter. This one here I can reduce. So I get square root of 34 over 3. This one I can reduce. Square root of 34, square root of 34. Why did I know that was going to happen? Square root of 34 over 5. And then you can reduce that one if you want to, or you can just leave it. I'm going to reduce it maybe if this quits doing that. 5 over 3. So there's my answers for those. Okay, those are co-functions. That's how you do it. All right, co-functions. One more, just for kicks and giggles and cashmeres. Here we go. So let's do this one in this nice green. All right, pick this up here. Boom, put that there. I'm going to put my angle up here at the top, call it angle B. Then I'm going to put over here 30. And let me erase it so it looks like a 30. I'm going to put a 30 there. And I'm going to put 24 here. So we got to find that one. Okay, we can't do these without it. So here we go. A squared, B squared, C squared. So A squared plus 24 squared is equal to 30 squared. So then I just got to figure out what that A or X is there. Whew. So now I'm going to it. So let's see here. Square root 900 minus 24 squared is 18. So that dude is 18. So now I can find it, right? So I'm going to go sine of B, that's up at the top, is equal to the opposite side 24 over the hypotenuse 30. Right? Cosine B is equal to, now stay with me, cosine B 18 over 30. Tangent B equals to opposite side 24 over adjacent 18. Right? Now I'm going to come, wow, look at that guy. Oh, now I'm going to do cosecant B. Flip it. 30 over 24. Okay. Secant B. Secant B. Pretty cool. 30 over 18. Cotangent B. 18 over 24. So all we're doing is flipping them. All right, that's all we're doing for those. Whew, that was a lot of stuff. Anywho, there it is. Don't forget to get those questions in. And this is a special week. Yeah, Monday off. But that means you still get to see me tomorrow. So I'm going to give you a couple problems to work on. And not a whole lot. And then tomorrow we'll do some more trig stuff. And that'll be it. Have a great and wonderful day.